This is the real Tom Rose, and they're asking us to generate a line. Now, they're asking us to generate a line, and they're not telling us quite enough to go straight to the answer, but they're giving us little clues that we can use. So one way to build a line is using what's called point-slope form. So if you have a point and a slope, then you can figure out an equation of a line. Point-slope form looks like this. It looks like y minus y1 equals mx minus x1, where y1 and x1, those are real coordinates. Those are coordinates of a real point, and m is the slope. And I'm guessing that we're going to use point-slope form based on what they give us. It says, so they, first of all, they tell us it has a y-intercept of -6. What that means is that the point 0, -6 is on the target line. So we already have the point, which means we can plug in for x and y. Sorry, x1 and y1. All we need now is the slope. But they've told us that our line is parallel to this line. Well, parallel lines, and this is something you needed to know coming in, parallel lines have equal slope. So if we can figure out the slope of this line, then we know the slope of our target line. So let's put this line into point-slope form. Sorry, let's put this line into slope-intercept form. You could do the other one, but it's just harder. So let's basically what I'm saying is solve this for y. So 6x plus 3y equals 4. Let's subtract 6x from both sides, and you'll end up with 3y equals -6x plus 4. Divide both sides by 3, and we get y equals -2x plus 4/3. And you can, when you have slope, a line in slope-intercept form, you can read the slope. This is y equals mx plus b, is slope-intercept form. You can read the slope off of, is the coefficient on that x term. So the slope of the target line is 2. Oh, sorry, -2. Now we can plug in and use our point-slope form equation. So let's do that. Let's plug that -2 in here, and we'll plug the 0, -6 in, and what we get is, let's see, y minus y1, which is -6, equals slope -2 times x minus x1, which is 0, and what you end up with is y plus 6 equals -2x. And let's subtract 6 from both sides, so you get y equals -2x minus 6, which is the fourth answer choice. So that was a cool question. It required you to use both slope-intercept form and point-slope form to generate and deconstruct lines, and also the knowledge that parallel lines have equal slope. Let me just show you why that's true. Right? Here's a plot, here's a line, here's another line. Slope is rise over run, right? So if these are parallel lines, won't the rise over the run of that line be the same as the rise over the run of this line? The answer is yes. You can kind of, this is not really a proof. This is kind of a geometrical, diagram that the slope is the same. But look at how the rise and the run is the same no matter where I draw it. No, any position, any line. That's a feature of lines and parallel lines, right? I'll put the fletchings on to show that's parallel. So even if you didn't know that, you could have maybe made that assumption, and it wouldn't have been a terrible assumption.